Let us compare the algorithms that we actually saw. We've seen the mark and sweep, and we've seen the Cheney algorithm, or two-finger algorithm. And let's compare them, their advantages and disadvantages. So there's actually three algorithms I want to compare. I want to compare the mark and sweep, the basic mark and sweep. I want to compare that to that Cheney algorithm, and I want to compare that to the mark and compact algorithm. Now, the first thing I want to bring up is the question of fragmentation. Now, we spoke about that already, and we said that mark and sweep actually has fragmentation, right? We get the memory slowly gets fragmented, and at some point, even if we have continuous memory, which is not, we don't know that it's continuous, and we think that it's not, mark and sweep is not going to know that. Mark and compact, on the other hand, fixes that problem because it does another pass on the memory, and what it does is it compacts all the live data into one location, and everything else becomes free. Cheney also does not have a fragmentation problem. Why not? Because if you think about it for a second, we copy all the live data into one location, and everything else is just free list, and everything else has been recycled. So when it comes to fragmentation, so in a sense, Cheney and mark and sweep do not have the problem, while mark and sweep does have the problem. Okay, the second thing I want to talk about is what's known as locality of reference. What is that? What is locality of reference? Well, we can assume pretty much that data that has been allocated at the same location in the code will probably be used together, right? If you have some piece of data that's allocated very far from another piece of data, it could be used with something else, but not necessarily, okay? But usually we find that data that's been allocated in certain places in the code is used together. And the question we need to ask ourselves is, do we have locality of reference in mark and sweep? And the answer to that is no. We do not have locality, which means we do not have locality of reference. Notice the word no. Why? Because of, well, it's a function of the fragmentation. Well, in a sense, we do have locality of reference in the beginning, but slowly as we get fragmented, right? So it becomes less and less local. So I wouldn't say a straight out no. I would say yes in the beginning and no as we progress. Does mark and compact have locality of reference? Well, since we do not have a fragmentation problem, right? And therefore data is usually allocated continuously one after the other. And therefore the fact that we actually move them afterwards into the beginning of the heap does not influence the locality of reference. And therefore this would probably have the answer to that would probably be yes, because the trait of mark and sweep of yes at the beginning and no as we progress stays a yes at mark and compact. What about Cheney? Well, Cheney, things are moved based on what we do allocate it in continuous memory. So memory that's allocated together will actually be continuous. But when they're copied afterwards from the two to the from to the two, that could change. So this is actually a question mark. Not necessarily very clear if we have locality of reference or not. How about the amount of work that needs to put in as a function, the amount of work as a function, the amount that you gain as a function of work? What does that mean? What I mean to say is the more work I put in, the more gain I expect. So mark and sweep, the answer to that is no, a definite no. And we talked about it before. The more work you put in, the less you actually get, right? It's actually counterintuitive. The same is true for the mark and compact for the same reason, right? You're actually putting more work because you're compacting it and you're actually getting less memory. But in Cheney, we are only touching the live data objects. We are not touching at all anything that's not alive, anything that's garbage. So here it's actually in line. It's actually in line, and the more work we put in, the more the gain is actually pretty good, right? But we actually only well, this actually should be question mark as well, because you could put in a lot of work and not gain anything. So this would be question mark as well. But you're only dealing with live objects and not dealing with dead objects, and therefore, if you have a lot of live objects and you're getting what you're supposed to be getting, so this is actually a question mark, a questionable point. How about memory waste? Let's call it Mem Efficiency. So Cheney is a very big no-no because it's actually wasting 50% of the memory, right? It's wasting 50% of the memory. While Mark and Compact is very memory efficient because it's actually only compacting the live objects and everything else becomes continuous. And Mark and Sweep, well, let's make it neutral because sometimes it's not able, again, because of the fragmentation, to utilize memory efficiently, and sometimes it is. So we'll keep it very neutral. And these are pretty much the advantages and disadvantages of comparison of all of these three algorithms.